We're going to do a few examples on mass stoichiometry. So we're going to go into our D2L page. We're going to go into content. I'm going to stop here and remind you that there is a tab where you can access the periodic table. I've got this open on my other window. And you're going to need that today because we are going to revisit molar masses and all of the masses of our elements on the periodic table. If I just go back to this content page, we want to scroll down to Unit 3, and we want to go down to Lesson 10. Okay, so even though this is numbered Lesson 10, we aren't actually doing anything new. We're using the concept of mole ratios from yesterday, and then we're going way back here, and we're using the concept of mass moles and molar mass. And as usual, you're going to click on Lesson 10. There's a What Do I Do page, and you want to have the resource note open and available. So the resource note, I have a link for you here, but it's always, present in one of the previous lessons. And we want to scroll down until we see Lesson 10 starting here. So we'll just wait because my Chromebook likes to freeze. There we go, we've gone too far. So you're going to see that right here, Lesson 10 begins here. And there's actually not a whole lot of note for you to read. What we're going to do today is we're going to take the concept of mole ratios that we learned yesterday. Okay, so right here, this is what we did yesterday, moles of given, and we were using a mole ratio in our balanced reaction to figure out the moles of unknown substance. But moles, while we need it and we need to use it when we're dealing with chemical reactions, it's much more convenient for us to be dealing with masses. So oftentimes when we carry out a reaction, we're starting with a mass of a reactant or maybe a mass of a product. And then they're asking us to calculate the mass of something else in the chemical reaction. And we'll go through 3 examples for you to see. But we still need a mole ratio in order to move between substances in a chemical reaction. The only difference is that we just maybe have to convert. So if they give us a mass, well, then we got to do a quick calculation to convert to moles. And when we calculate the moles of our unknown, this is where we stopped in our last lesson. Well, now we're just going to do a quick calculation and we're going to convert our moles into a mass using molar masses. Okay, so none of this is actually new, but we are revisiting some ideas and we're putting it all together in this branch of chemistry called stoichiometry. So you have a summary note here that I have for you. And what I ask is for you to summarize the 3 steps needed to complete mass stoichiometry. Again, this is them right here. Follow the arrows. Each arrow represents 1 step. And then we are going to go through these 3 examples together. Okay. And then you have 2 questions to try. I've provided answers for you so that you can try them, pardon me, and see if you can get the answers required. This branch of chemistry is really interesting, and it's kind of exciting that you're doing this because this is the kind of chemistry and calculations that is done in industry. So I'm going to open up a Jamboard and we'll go through all 3 examples together. Okay, so this first question is saying, calculate the mass of oxygen required to burn 60 grams of carbon. So yesterday we would have been asking you to calculate the moles. We would have given you a mole value to start with. The only difference today is that we are going to have to either calculate moles ourselves or go from a mole value and convert over to mass. So I'm just going to get my pen ready here. And we will start. There are 3 steps. So the first step that we do is we calculate, and I'm just going to write out the steps for this first example, and then I'm not going to be writing these sentences. Calculate the moles of your known value. Okay, so what is it that I know? Well, I know that I have 60 grams of carbon. And then they are asking us to calculate the mass of oxygen. So that's my unknown amount. So what we'll do is, because we know that we have 60 grams of carbon, let's calculate the moles of carbon. And we're going to use our formula, mass over molar mass. So it's been a little while since we've used it, but that's okay. And we're going to sub in 60 grams. And we're going to divide by the molar mass of carbon. So don't forget how we get that. You get your periodic table handy here. And then we come over and we see carbon has a molar mass of 1201 grams per mole. And get your calculators out and just follow along with me so that you're getting the right numbers. So 60 divided by 1201 is going to give us roughly 5 moles. Okay, so I'll hang on to several decimal places here. So 49958, that should be lots. And now we know the moles of carbon. Well, step 2 requires us to set up a mole ratio, because what we have to do is we have to move from carbon over to oxygen. That's what they're asking us to solve for. So this is where we now set up the mole ratio. And remember what we do. We put our unknown in the numerator. So we want to figure out the moles of oxygen. And we compare to the actual values out of the question. Now, again, they didn't actually give me this mole value of carbon, but they gave me a mass, and then I could calculate the moles of carbon as a result. When I look at the coefficients, everybody is a 1-to-1 ratio. So that means that I'm going to have the exact same values here. So moles of O2 and moles of carbon are exactly the same. It's a 1-to-1 ratio. So my moles of oxygen equals 4.9958 moles. And then the last thing that I need to do is I have to figure out the mass of oxygen. Okay, so yesterday we just would have been sort of stuck on step 2. Now today we can do step 3, which is calculating the mass of O2. That's a 2. And we're going to do that by taking moles times the molar mass of oxygen. So I'm going to take 4.9958 mole, and then I'm going to multiply that by the molar mass of oxygen. So remember, go to the periodic table. There's oxygen right there, 16 grams per mole. But in my formula, I have 2 oxygen atoms. So it's actually times 32 grams per mole. And when I calculate that, and when you calculate that, just to verify, I'm getting an answer of 159.87 grams. Okay, so it's 3 steps. And it's very similar to what we did yesterday. So you have to use a mole ratio to move between substances. That has not changed, but we've just added on our mole formulas before and after. Here's another example. So it says that we have the balanced equation for the combustion of ethanol. And it says what mass of carbon dioxide, so this is my unknown, will be produced when 9.20 grams of ethanol is completely consumed. So I have to start with the mass that they give me. And the first thing that I want to do is I want to calculate the moles of that substance. So ethanol is C2H5OH. And I know its mass. So I'm going to take mass divided by molar mass. I'm going to take 9.20 grams, and I'm going to divide by the molar mass of ethanol. So there's several atoms here, so be careful. There's 2 carbons, so 2 times 1201. And then I'm going to add on 5 hydrogens, and hydrogen is 101. So we'll add that up. We're going to add on an oxygen, which is 16, and we're going to add on 1 more hydrogen, which is 101. I'm getting a molar mass of 46.08 grams per mole. I hope you are too. So we're going to divide that out, and we're going to see how many moles that works out to be. So I'm getting an answer of 0.19965 moles. Step 2 is for me to go from ethanol over to, what do they ask us for? Carbon dioxide. So we're going to move and we're going to mole ratio over to CO2. So we'll set up our mole ratio and we put the moles of carbon dioxide in the numerator. We compare that to the actual mole value that we just solved for. And that is for ethanol, so C2H5OH. And then we equate that to the coefficients. So for carbon dioxide, 2 moles of CO2 would be created if 1 mole of ethanol was reacted. But I don't have 1 mole of ethanol. I have 0.19965. But still, the proportion is a 1 to 2. So I'm going to take this value, I'm going to cross multiply it by 2, and I'm going to divide it by 1. So I get an answer, or a mole value of CO2 that is 0.39931 mole. And then the question is asking, what is the mass of carbon dioxide? So I have to calculate the mass of carbon dioxide. I only know the mole value. So we're going to do a third step, and we're going to set up the mass of CO2, which is taking moles times the molar mass. So we take 0.39931 mole, and then the molar mass of carbon dioxide is 32 for oxygen and 1201. So 32 and 12 is 44.01 grams per mole. And then when we multiply that through, I'm getting an answer of 17.57 grams. Okay, so it's always these same 3 steps, and then it's up to you. You got to find what mass did they give you, which substance. You calculate the moles of it. Then you set up your mole ratio right here with whatever unknown they're asking you for. And then lastly, you calculate the mass of the substance that they're asking for. Okay, so the third example is similar to the first. It says, again, the balanced equation for the combustion of ethanol is given there. And it says what mass of oxygen is required. So because they're using the same reaction, they're going to assume that we're still using a mass of ethanol from the previous example. That was 9.20 grams. Okay, so what we'll do is we will calculate the moles of ethanol again. So C2H5OH, and we're using mass over molar mass. We're taking 9.20 grams, and we're dividing by the molar mass of ethanol, which again, we can just look back at the previous question, but we'll just do it here quickly. So I'm getting 46.08, and we're going to divide that out. So 9.2 divided by 46.08 gives me this value of 0.19965 moles. And then they're asking us to calculate the mass of oxygen. So I'm going to have to mole ratio from ethanol over to oxygen. And notice the coefficients. That is a 1 to 3 ratio. So I'm going to set this up and figure out how many moles of oxygen I will be making. And then I'll convert to mass. So I'm comparing that to 0.19965 moles of ethanol, C2H5OH. And then remember that we put the coefficients for each and line up those coefficients. If oxygen is in your numerator, because it's the unknown, you got to put the coefficient for oxygen in the numerator. If your known value is ethanol, then you need the coefficient for ethanol in the denominator. Okay, so again, you know what these coefficients mean. If I had 1 mole of ethanol, and I don't, I have 0.2. If I had 1 mole of ethanol, I would need 3 moles of oxygen to react. And I don't have 1 mole, I have 0.2 over here, but I still need a 1-to-3 proportion. So we're just going to cross multiply by 3 and divide by 1. So I'm getting a mole value of O2. That works out to be 0.5989 moles. Okay, so again, hopefully you're following along. We just took this value here, we cross multiplied it by 3, and we divided it by 1. Last step, because it's a 3-step method, we're going to figure out the mass of oxygen, and we're going to take moles times the molar mass of oxygen. So we've got 0.59895 mole, and then the molar mass of oxygen is 16. There's 2 of them. That would be 32.00 grams per mole. And then we report an answer to 2 decimal places is usually good enough. So when I multiply those together, I'm getting a value of 19.17 grams. Okay, so there we go. A few examples done using this 3-step method. So again, make sure that you write down the 3 steps from the resource note, and then try the last 2 examples on your own using these methods that I'm showing you.